told me this. You ever had to personal driving license?
No, never had any of his driving.
Okay.
Get out of here!
Have you ever wondered how or why the periodic table is set up as it is? Why the elements are arranged the way they are? There are real patterns or trends in the way it is made up. We will get into that a little more later, but first a short history of the periodic table. In 1828, Dr. Dobrynin was the first to arrange the elements in any sort of order. He arranged them in sets of 3 elements or triads which had similar properties. Then 36 years later, in 1864, a man named Dr. Newlands did the same thing, only arranged the elements in sets of 8, also called octaves. A major change came in 1869 when Dr. Menletter was the first person to arrange the elements by their atomic number. Then around 1900, Dr. Moseley, using X-ray diffraction, arranged the elements by their rising atomic number. He also left spaces between the elements because he knew that there were other elements yet to be discovered. He also developed the periodic table, which is considered very important today. It is the following. Physical and chemical properties of elements are periodic functions of their atomic number. Properties of elements go through patterns of change, and elements of similar properties occur at certain intervals. Besides the expected adding of new elements, the periodic table stayed pretty much the same through the present. Now back to the trends. Each vertical row is called a family or group. Each group going across are called series. There are 8 groups of elements, each with specific properties for the group. Okay. Part of each element's properties, besides things like melting point, boiling point, and other common properties, are properties such as the ionization energy of an element, which is the amount of energy required to take away an electron from the element. This too, along with other properties like the element's electron affinity, are also arranged in trends on the periodic table. These unfamiliar properties are ionization energy, the amount of energy required to take away one electron; electron affinity, the amount of energy required to gain an electron; ionic radius, the distance across an ion; atomic radius, the distance across from the nucleus to the outer shell; and metallic and non-metallic properties. These properties have certain trends going across and down on the periodic table, as shown on this chart, so every aspect of the periodic table is completely fitted together, as logical as is possible to be. Back in 1828, Dr. Dobrynin never thought that in the future his simple triads would be expanded this far. These trends make it easier for students and scientists to use the periodic table. I hope you have learned something about the periodic table and how it was put together. Thank you and goodbye.